Hello everyone, welcome in my YouTube video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. In this session we are going to start the new chapter which is loci of points. So next let us understand what is loci of points. The word loci is a plural of the word locus. Locus of a point is a path traced out by a point while moving in a plane or space according to a given law. Next, let us understand locus of point moving in a plane and equidistance from a fixed point. Here, O point is a fixed point. This point P is moving point. O to P consider R radius, and from O fixed point this circle is indicate here locus of P point which is moving point, and the distance of P point is fixed from O point. So this circle indicate here locus of or loci of P point. Next, let us understand locus of point P moving in a plane and equidistance from two fixed point. Here, these 2 points indicate fixed point A and B. Next, take radius AB, center B and draw two arcs. One is above AB line and another is below AB line. Similarly, take center A, radius AB and draw two arcs. One is above AB line and another is below AB line, which is intersect at one point on previous two arcs of fixed point B. Connect these two intersecting point as a line, and this line indicate locus of point P. Here the locus of point P distance is fixed from two fixed point A and B. Next, let us understand types of mechanism. First mechanism is slider crank chain. Two types of slider crank chain. One is simple and second is offset. Next, 4-bar chain. First part of 4-bar chain mechanism in which both the driver and driven cranks revolving. Second, driver crank revolving and driven crank oscillating. Third, both driver and driven cranks oscillating. Next, crank and connecting rod mechanism with connecting rod constrained to pass through guide named as Trunnion. Next, combine of above mechanism. So next let us understand example of simple slider crank chain mechanism. In a slider crank mechanism, the connection of rod is 160 mm and crank is 40 mm in length. The other end point of the connecting rod on the slider move along a straight line passing through center of crank rotation. Trace the locus of midpoint P of the connecting rod. Here you can see OA indicate crank. Now this circle is a locus of A point which is moving point from fixed point O. Now this B point is indicate here slider, and the motion of this slider is sliding on this horizontal path which is passing through O center. AB indicate here connecting rod which is connect crank and slider. Here When the crank is complete one revolution, at that time we need to draw locus of P point, and P is the midpoint of connecting rod AB. So first draw circle. Take radius of circle is 40 mm or 4 centimeter. O is the center of circle. Here this circle is locus of A point, which is moving point. So for uniform position of crank for one complete revolution, divide this circle into equal 8 parts at 45-degree angle. Next, locate position of crank. Here this OA1, this initial position of crank. Next A2, A3, A4, A5, A6, A7 and A8. Next draw horizontal path passing through center point of circle O. Here we need to find position of slider for each and every position of crank. First consider A1 position of crank and find out B1 position of slider on this horizontal path. Now the length of connecting rod which connect crank and slider is 160 mm. So take radius 16 centimeter, center A1 and cut arc on this horizontal path and mark here B1 point. Connect A1 B1 connecting rod and locate midpoint of A1 B1 connecting rod, and this midpoint indicate here locus of P1 for A1 position of crank. Next, for A2 position of crank, find out position of B2 slider on this horizontal path. So take center A2, radius 16 centimeter and cut arc on this horizontal path and mark here B2 point. Connect A2 B2 connecting rod and mark midpoint of A2 B2 and which is indicate locus of P2 point. Similarly, take center A3 and cut arc, find out B3, connect A3 B3 and locate midpoint P3. Next, take center A4 and cut arc and find out B4, connect A4 B4 and locate midpoint P4. Similarly, for A5, A6, A7 and A8 position, find out slider position of B5, B6, B7 and B8. Here you can see the angle of A5 and A3 position of crank is same from this horizontal reference. So the position of B5 slider for A5 position of crank is at B3 position of slider. So here mark B5 point, connect A5 B5 and locate midpoint P5. Same for A6 and A2 position, the position of slider is at same place. So here mark B6 point, connect A6 B6 point and locate midpoint P6. Similarly, locate B7 point at B1 point because the angle of A1 and A7 crank from horizontal reference is same. So mark here B7 point, connect A7 and B7, locate its midpoint P7. Now for A8 position of crank, draw arc on this horizontal path, radius 16 centimeter and locate here B8 position of slider. Connect A8 and B8 point and locate its midpoint P8. Next, connect P1 to P8 locus point freehandly in form of curve, which is indicate locus of P point for one complete revolution of crank. So, this is the example of simple slider crank chain mechanism. Next, let us understand example of offset simple slider crank mechanism. In a mechanism shown in figure, crank OA rotates about O and end B of the rod AB slide on a straight line. Draw the locus of point P on the rod AB 40 mm from B for one complete revolution of OA. Here you can see OA indicate crank, O is a fixed point, A is a moving point. The path of A point is a circle. The length of connecting rod is given 40 mm. Here the path of slider B is given offset and offset distance is given 20 mm below from horizontal path passing through O point. Here P point is a locus of point for complete one revolution of crank OA on connecting rod AB. The distance of P point is given 40 mm from B point. Next, let us solve this example with dimension. First draw 40 mm radius circle from O point. This circle indicate locus of A point. Divide this circle into equal 8 parts for uniform position of crank OA. Mark here crank position as A1, A2, A3, A4, A5, A6, A7, A8. Locate its position either in clockwise or in anticlockwise. Here I have located the position of crank in anticlockwise direction. Next, draw the path of slider B, which is offset, and offset distance is given 20 mm from path of O. So locate path of slider B, 20 mm offset distance is given from horizontal path of O point. Now here same drawing step we have to apply as per previous sum. For different position of crank we need to find here the position of slider on this offset path. The length of connecting rod is given 160 mm, which is connect crank and slider. So take radius 16 cm, center A1 and cut arc on offset slider path and mark here B1 slider position. Connect A1 B1 and locate P1 locus. Distance of P1 locus from B1 point is 40 mm or 4 cm. Similarly, take center A2, radius same is equal to connecting rod and cut arc on offset path and mark here B2 point. Connect A2 B2 and locate P2 locus from B2 point. Distance is 40 mm. Same, take center A3 and cut arc on offset path and find out B3. Connect A3 B3 and locate P3. Distance 40 mm from B3. For A4 position of crank, find out B4 slider position. Connect A4 B4. Locate P4 on connecting rod A4 B4. Next, take center A5, radius same 16 cm and cut arc on offset path and mark here B5 slider position. Connect A5 B5 and locate P5 on connecting rod. Distance from B5 is 4 cm. Similarly, find out B6 from A6, connect A6 B6 and on A6 B6 connecting road, locate P6 locus at distance 4 cm from B6. From A7 position of crank, find out B7 slider position, connect A7 B7 and on A7 B7 connecting road, locate P7 locus. From A8 position of crank, find out B8 position of slider on this offset path, connect A8 and B8 point and locate P8 on A8 B8 connecting road and the distance of P8 is 4 cm from B8 position. Now connect this all locus point freehandly in form of curve. So this is the example of offset slider crank chain mechanism. Next, let us understand example of Trunnion mechanism. In the mechanism shown in figure, the connecting rod is constrained to pass through the trunnion at D. Trace the locus of the end C on BC for one complete revolution of the crank. In figure, consider AB as 30 mm. Here you can see AB indicate crank. This circle is a path of B point. A point is a fixed point. D point is also fixed point and which is indicate Trunnion point. The distance of Trunnion point is given. Horizontal distance from A point is given 70 mm and vertical offset distance from horizontal path which is passing through A point is given 12 mm. The length of BC road which is passing through Trunnion point D is given 140 mm. Next, let us solve this example with dimension. First, draw circle which is indicate path of B point. The radius of circle is 30 mm because the length of AB crank is given 30 mm. So, diameter of this circle is 60 mm. Next, divide this circle into equal 8 parts at 45° angle for uniform position of crank for complete one revolution. Mark here crank end point B1, B2, B3, B4, B5, B6, B7 and B8. Next, locate Trunnion point D. Now, horizontal distance for this Trunnion point D is given 70 mm and offset distance from horizontal path passing through center point of this circle is given 12 mm. Now, in this mechanism, at every position of crank, rod BC is always passing through Trunnion point. So, connect B1 D point and take total length is 14 cm because the length of BC rod is given 140 mm and at end point locate here C1 point. For C2 point location, connect B2 D point, take total length is 14 cm and at end point of B2D road, locate here C2 point. Similarly, find out C3, C4, C5, C6, C7 and C8 point. Here, at each and every position of crank, rod BC always passing through fixed Trunnion point D. Next, connect endpoint of BC road C1, C2, C3 up to C8 freehandly in form of curve, which is indicate locus of C point. So, this is the end of this session. See you soon in next coming video lecture. Thank you.